Hello everyone. In this video, we will learn following topics. We will learn what is science and technology. We will learn what is chemistry, what is matter, classification of matter, physical transformation of matter, chemical transformation of matter, and at the end, we will learn the scientific method. So let's start with the first topic, which is science and technology. So science is the experimental investigation and subsequent explanation of natural phenomena. In scientific investigation, we observe things, we perform series of experiments to collect data, and use that data to explain natural phenomena. Technology, on the other hand, is the application of scientific knowledge. Science itself cannot help the world unless we convert the scientific knowledge into technology. We can say that science is the pipeline for the technology, feeding it and supplying it with ideas. Because science feeds ideas to technology, it is not a bad idea to have a question: is science always right? For this, let's look at these headlines from the history. We have a headline in 1977 that FDA proposes banning saccharin as carcinogen. In year 2000, saccharin removed from the cancer list. In 1985, unsaturated fats good for health, and in 1994, unsaturated fats not so good for health. In 1999, new arthritis drugs a miracle, and in 2005, new arthritis drugs linked to the heart attack. So what is going on? The answer to this is that science is an evolving understanding of natural phenomena. Things that we thought we understood in the past, we might have a very different understanding right now. We may have a new data and new ways of understanding things. So science is not static, it is dynamic. Things are constantly changing. So let's look at our next topic. What is chemistry? Chemistry is scientific study of matter at the atomic and molecular level and the changes it undergoes. There are many underlined words, and to understand this definition, we have to understand all these underlined words one by one. Scientific study, scientific refers back to the definition of science, which means this study is experimental investigation and subsequent explanation of matter. We will then define matter in next few slides. We have to understand what atomic and molecular level means. So atomic and molecular level defines the scale of the size. A very small scale of size. So in chemistry, we zoom in and look at the things at very, very small level. The last thing that is underlined is the changes that matter undergoes. So chemistry is really the science about studying the changes of these things. This leads to our next question: what is matter? So matter is defined as anything that has mass and occupies space or have some volume. Most of the things around you are matter. For example, in this image, the person or you itself, you are matter. Then glasses, butterfly, computer, coffee, desk, chair, plant, cat, clouds, sun, all these things are matter around you. So most of the things are matter, but not everything is matter. Non-matter includes light from the torch, heat from the fire, sound from the police siren. So those are the types of non-matter, and they are actually the form of energy. They don't have mass, they don't take space. To fully understand matter, we will see the classification of matter. Broadly speaking, the matter can be divided in two categories: pure substance and mixture. So let's first take a look of pure substance. What it means by pure substance? Well, The pure substance is something that is made up of one chemical structure, either an element or a compound, meaning that pure substance can be further subdivided into element and a compound. Elemental substance consists of a single element. Example for elements are like hydrogen, oxygen, sodium, etc., etc. We will learn about elements in detail in next slide. Compound, on the other hand, is made up of two or more types of atoms that are chemically bound together. For example, water, H2O, carbon dioxide, CO2, NaCl, sodium chloride or table salt, etc., etc. Now let's take a look at the second type of matter, which is mixture. Mixtures are combination of two or more substances that are physically mixed together but are not chemically combined. There's no chemical bond in a mixture. A mixture can be subdivided into homogeneous mixture and heterogeneous mixture. Homogeneous mixtures have uniform composition. They made up of two or more substances, but the composition is uniform throughout the mixture. For example, when we dissolve salt in water, you will not able to identify the salt particles in that glass of water. The composition will be uniform throughout that glass of water. Or another example, dissolving a sugar in a cup of tea. After dissolving it, you will just get a homogeneous mixture and you will not able to identify sugar particles in that cup of tea. Another example of a homogeneous mixture is air. Even though we cannot see air, and air is made up of many gases, but the composition of all gases inside the air is uniform. These mixtures are made up of more than one substances, but by looking at the mixture, you cannot simply tell that if it has more than one substances, as it just appear like one uniform substance. Like if you dissolve salt in a water, you will not able to know whether there is salt in it or not. It will just appear uniform or the pure substance or the same thing throughout. The next mixture that we have is heterogeneous mixture. This mixture have variable composition. Best example here is a mixture of oil and water. And oil and water will never make a uniform solution. They will never blend each other. And you can see both substances separately even by naked eye. You don't even have to zoom into the atomic or molecular level. Another example of a heterogeneous mixture is seawater. If you take a cup of seawater, what you will have in it is you will have water, you will have salt, you will have some sand, some debris, some broken shells, etc., etc. So that will also be the example of a heterogeneous mixture. Now let's look at these four categories of matter at the molecular or atomic or molecular level. Okay. So element, when we look at the atomic level, element is consist of single element. And in this zoomed version, you can see all atoms are identical. Okay. And that is the property that all atoms in an element will be identical. So you will see that all are same. And if we zoom in for a compound, you will see the pure compound, but there is only one type of compound. Then if you zoom in on a homogeneous mixture at the molecular level, you will see different pure substances, but the mixture is uniform throughout, or substances are evenly distributed in this mixture. For heterogeneous mixture, you don't even actually need to zoom in to the molecular level because you can identify even from the naked eye that the composition is not identical throughout this mixture. Some more examples for heterogeneous mixtures are chocolate chip cookies, salad dressing, a mixture of table salt and table sugar. Now let's take a look at the elements in detail. An element is a substance that cannot be decomposed or transformed into other chemical substances by ordinary chemical processes. At present, 118 elements are known, and 94 of them occur naturally, and 24 can be synthetically prepared in the laboratories, in nuclear reactors, or in nuclear explosions. All 118 elements are arranged in a table called a periodic table. And we use symbols to represent these elements. So you can see that for hydrogen, the symbol is H, for lithium, Li, for sodium, Na. So we use symbols to represent these elements. And your first homework from this chapter is to memorize the names of elements and their respective symbols. Okay, so here is your first homework, that you have to know at least first 36 elements in the periodic table, and then following most commonly used elements in Chem 108. Now let's look at the compound in detail. A compound is a pure substance formed when two or more elements are chemically joined. And in Chemical Abstract Service, more than 164 million unique organic and inorganic substances are recorded. So if you compare with the number of 118 elements to the number of compounds that we know as of now, there's huge difference. There's a huge possibility of making new compounds out of these 118 elements. So there are a lot of combinations possible. And approximately up to 4,000 new substances are being added every day. And we use a chemical formula to represent compound, and we will learn in later chapters on how to write chemical formula. But for today's lecture or today's class, it is just that a compound is a pure substance formed when two or more elements are chemically joined. Okay, so now let's take a look of the difference between element and compound. Both element and compound are pure substances, right? But there's a difference between these two. An element cannot be broken down into simpler substances. It just consists of one type of atom. Compounds can be broken down into simpler substances, that is, into simple compounds or elements. It is because they are made up of different elements, so there is possibility to break them back into simpler substances. So now let's look at the definition of chemistry one more time to see what we have learned so far. So we have learned about scientific study, right? We have learned about matter and its categories or its types. And we looked at those categories at the atomic and molecular level. And now the last piece in this definition is to understand changes of matter that it undergoes. Scientific terminology for changes is transformations. Let's look at the transformation of matter. There are two transformations of matter: physical transformation and chemical transformation. Physical transformation is converting matter from one state to another state, and no new substances are formed in physical transformation. On the other hand, chemical transformation is converting one or more substances into new substances, and those new substances will have new physical and chemical properties. So in chemical transformation, the product will have a new chemical composition. So before we look at the physical transformations, the types of the physical transformations, let's look at the states or phases of matter. There are three phases of matter. These are the most common phases of matter, actually. There are more than three, but for Chem 108 course, we are only going to look at these three phases of matter. So in solid, the particles are touching each other with a very little space between them. In liquid, the particles are usually still touching, but there are some spaces between them, you can see here. And in gas, particles have big distances between them. Let's look at the terminology used for different physical transformation. So the physical transformation, if it is a phase change from solid to liquid, it is called melting. If it is a phase change from liquid to solid, it is called freezing. From liquid to gas is called evaporating, and from gas to liquid is called condensation. These are the most common order of phase transformation, like solid to liquid and liquid to gas. However, there are some substances that skip the liquid phase and change straight from solid to gas or gas to solid. So those are called, if it is a change from solid to gas, it is called sublimation, and if it is gas to solid, it is called deposition. So let's look at those two special type of phase transformation or physical transformation. Sublimation is a process by which molecules go directly from solid into the vapor or gas phase without passing through the liquid state. Example for that is carbon dioxide. The carbon dioxide exists as a solid at minus or below minus 78 degrees Celsius. But if you warm it above this temperature, it slowly vanishes into thin air. Unlike when ice melts, it will give you the puddle of water. The other examples include air fresheners. The solid in an air freshener can sublimate in order to make the room smell nice. Another example is naphthalene, which is used to make mothballs, is example of odorous sublimation. It sublimates quickly and smell keeps the moths away. For deposition, this is a process by which molecules go directly from gas phase into the solid phase. Example of deposition is formation of frost. When it is below zero outside, it becomes so cold that any water vapor goes straight from water phase into the solid phase. And that's why you see frost the first thing in the morning. You won't see the frost during the daytime. Another example of deposition is snow that is formed in clouds. Water vapor changes directly to ice without first becoming into the liquid. So here I have examples of chemical transformation. We saw the definition of chemical transformation in one of the previous slide, that chemical transformation is converting one or more substances into new substances having new physical and chemical properties. So one of the example is burning of wood. So wood is made up of hydrocarbons. Hydrocarbons are carbon and hydrogen, right? So on burning in oxygen, hydrocarbon will convert into carbon dioxide and water. And wood cannot be recovered from carbon dioxide and water. So what happened here is that its chemical composition changes during burning. Few more examples I have here is raw egg becomes cooked egg, cake mix becomes cake, paper becomes ash, and steel becomes rust. So all these are the examples of chemical transformations. The last topic that we have in today's video is scientific method. Scientific method refers to the process that scientists use to investigate the universe based on observations, logic, and reasoning. There are 6 steps in a scientific method, and the first step in the scientific method is question or making observation. So the study begins by making a question on some observation that you are curious about, and then you are formulating a hypothesis based on that observation. So the second step is hypothesis. A hypothesis is a possible explanation of your question. It is just an educated guess that needs to be tested. The third step is experiment or testing. An experiment is carried out to test a hypothesis. This involves gathering new information that enables a scientist to decide whether a hypothesis is valid or not. The fourth step is collecting scientific data. The facts that we obtain through the careful observation and measurements that are made in the experiment step are called scientific data. Based on this scientific data, a scientific law is summarized outcome of this series of experiment after the analysis. The last step in the scientific method is the report or the theory. A theory provides explanation of observed natural phenomena, and it can be tested by further experiments. If further experiments cannot produce the results that the theory would predict, this theory will be rejected and a new hypothesis will be created. And this new hypothesis will be tested again. There will be new data and new analysis, new scientific law, and a new theory. This process will be repeated until the theory can put forth the consistent result with this experimental data. So that is all for our today's class or today's lecture. See you guys next time. Bye.